All right, guys, so today we are going to go over solution stoichiometry. So what we're going to see is that in chemical reactions, most of the time we can't take two solids and mix those reactants together and get a reaction to occur. Instead, we usually have to dissolve the solids in water. And as soon as we dissolve them in water, now we have a solution. And when we have a solution, we know that molarity is going to be an important way to express the concentration. So molarity is equal to moles over liters. This equation is going to be important in that it tells us the ratio of solute that's dissolved to water or solution that it's dissolved in. If you need a refresher on molarity and how to use that molarity equation, please check out my earlier video that's linked above. Let's start with a problem that involves a solution as well as stoichiometry, or comparing amounts in a chemical reaction. So I want to know how many milliliters of 0.5 molar NaI are needed to produce 1.8 grams of PbI2. The balanced equation is the first important part to this, and notice that the balanced equation is written here below. The trickiest part to these problems is knowing where do I start and where am I going. The order or the steps in which we do things change every single problem, so it's important to have a way to organize the problem prior to starting the math. I suggest going through and identifying what all of your numbers represent and what substance they're referring to. I like to list them out underneath the substance they're referring to in the balanced equation. So the first number here that I hit is a 0.5 molarity. That is referring to the NaI. So in my balanced equation underneath the sodium iodide, I am going to put that number. I want to know how much is needed to produce 1.8 grams, and that 1.8 grams is referring to the PbI2. So I'm going to find the PbI2 in the balanced equation, and I'm going to write the 1.82 grams underneath it. Now that I've identified what all of my numbers are referencing, we want to identify what it is that we're trying to find. In the problem, it says how many milliliters. So ultimately, I'm looking for milliliters, and specifically milliliters of NaI. Milliliters is a measure of volume, and that volume directly connects to liters. We have a conversion from milliliters to liters. If I can find liters, then I can easily convert that into milliliters. So now that we have all of our numbers organized, we need to figure out a plan. If I ultimately want to find the liters of NaI, and I know the molarity of the NaI, the only missing piece of information is moles of NaI. If I can find the moles, then I can solve this problem. Now, if I have 1.82 grams of PbI2, I can find the grams or the moles of any other substance in this balanced equation using my stoichiometry. So I can use my stoichiometry to convert my grams of PbI2 in order to get moles of NaI. We're going to start with the 1.82 grams of PbI2. I need to convert those grams into moles. In order to do that, I'm going to go to the periodic table and add up the molar mass of PbI2, which is 461.01. That many grams of PbI2 is equivalent to 1 mole of PbI2. Now, if I stop the problem here, I have moles of PbI2. But remember that my ultimate goal here is to get moles of NaI. So I'm going to have to go one step further and use the mole ratio. According to the balanced equation, the mole ratio is 1 to 2. So for every 1 mole of PbI2, I need 2 moles of NaI. Now I have moles of NaI, and that's what I need in order to finish the problem. So I'm going to solve by multiplying everything on the top together, multiplying everything on the bottom together, and dividing my top by my bottom. When I do that, I get 0.00781 moles of NaI. Now that I know the moles and the molarity of the NaI, I can use my molarity equation to solve for the liters. Let's go ahead and plug that in. It's important to remember that when you're using the molarity equation, every single number that goes into that molarity equation needs to be in reference to the same substance. In this case, the NaI. So I have 0.5 as my molarity. I know the moles, 0.00781, and I'm looking for the liters. If you're not sure how to solve this algebraically, I would suggest putting your molarity over 1, and then you can set it up as a cross multiplication problem. When I do that, I end up with x equals 0.0156. The unit on that is liters. So now I have liters of NaI. But remember that the ultimate goal here was to get milliliters, and we know that there are 1,000 milliliters in 1 liter. We can do a conversion, and I'll need to multiply my 0.016 times 1,000 to give me 15.6 milliliters. Again, those are my milliliters of NaI. So if I go back to the problem, it's important to remember what these numbers mean. If I want to make 1.82 grams of PbI2 as my product, I would have to start with 15.6 milliliters of my 0.5 molar NaI. All right, let's look at a second example. I want to approach this the same way. I'm going to start with the numbers that are given in the problem, and I'm going to identify what substance they're referring to. So my 0.15 molarity is referring to my NaNO3. So I'm going to write that molarity underneath. I get 25 milliliters of a 0.5 molar MgCl2 solution. So the molarity of the MgCl2 is 0.5, and the milliliters here are also referring to that same 0.5 molar MgCl2. Milliliters are not super helpful to us, so we're going to need to take those milliliters and convert them into liters by dividing by 1,000. That is going to give me 0.025 liters. As soon as I've identified all of my numbers, I need to figure out what is my end point. My end goal here is to get milliliters of NaNO3. Remember that liters will connect to milliliters, so if I can find liters, I can solve the problem. Looking at what I have, remember that I'm going to need to use my molarity equation, which is molarity equals moles over liters. As soon as I have 2 out of the 3 variables, I can solve for the missing variable. So if I look at my MgCl2, I have the molarity and I have the liters. Because I have 2 out of the 3 variables, I'm going to be able to solve for my moles. Remember that those moles represent moles of MgCl2, and ultimately, I want liters or volume of my NaNO3. The only way to compare 2 different substances in a balanced equation is through the mole ratio. So I know that my NaNO3 and my MgCl2 have a 2-to-1 mole ratio, so I can figure out how many moles of NaNO3 using that mole ratio. And once I have my mole ratio and my molarity of my NaNO3, I'll be able to solve for those liters. I'm going to start with the MgCl2, and I know the molarity. I don't know the moles, but I do know the liters. I can solve for my x, and when I solve for x, I get 0.0125, and that's moles. Remember, though, that that's moles of MgCl2. So I now know this number right here. Now that I know moles of MgCl2, I can use my mole ratio in order to solve for moles of NaNO3. According to the balanced equation, there's a 2-to-1 ratio, so for every 1 mole of MgCl2, I need 2 moles of NaNO3. Now I have those moles of NaNO3. I can multiply across the top to solve, and I have 0.025 moles of NaNO3. I now know this number right here. My ultimate goal was to find liters of NaNO3, and I now know the molarity and the moles of NaNO3. I'm ready to use my molarity equation one more time, this time in reference to the NaNO3. The molarity is 0.15, the moles are 0.025, and I'm solving for my x value, or my liters. If you're not sure how to solve this algebraically, I would suggest putting your molarity over 1 and cross multiplying. That's going to give me 0.15x is equal to 0.025. My x can be found by dividing both sides by 0.15, and x is then equal to 0.17. Remember that x is representing my liters, so I have 0.17 liters. The problem asked me for milliliters, so I'm going to need to do a conversion by multiplying by 1,000. 1 liter is equivalent to 1,000 milliliters, and that is going to equal 170 milliliters. So I know that I'm going to need 170 milliliters of the 0.15 molar NaNO3 to fully react with the MgCl2. All right, let's look at one last problem. This time, I want to know how many grams of NaCl can be produced when 10 milliliters of 0.19 molar MgCl2 reacts with NaNO3. We're going to start this problem the exact same way. We're going to go through and identify what all of our numbers refer to. So I know that I have 0.19 molar MgCl2, so I'm going to list that underneath the MgCl2. I also know that I have 10 milliliters of that MgCl2. Remember that milliliters are not super helpful, but we can use milliliters to convert into liters. There are 1,000 milliliters in 1 liter, so I have 0.01 liters. All right, let's identify the end goal here. The end goal is to find grams of NaCl. I know that molarity is equal to moles over liters. I have the molarity and the liters of my MgCl2, so I can use this information to calculate my moles. Once I have my moles of MgCl2, I can then use my mole ratio in order to find my grams of NaCl. My molarity is equal to my moles over my liters, so I'm going to start with the MgCl2 since I know 2 out of the 3 variables. I can solve for the third. 0.19 is my molarity. I don't know my moles, so I'm going to call that x, and my liters are 0.01. Make sure that you're using liters in your molarity equation, not milliliters, so this conversion is necessary. When I solve, my x value is 0.0019, and remember that that represents moles, and specifically moles of MgCl2. Now that I know my moles of MgCl2, I can use my stoichiometry to convert that into moles of NaCl using the ratio from the balanced equation. For every 1 mole of MgCl2, I know that I'm going to produce 2 moles of NaCl. If I stop the problem right now, I have moles of NaCl, but the problem asked me for grams of NaCl. That means that I'm going to go one step further, and to get from moles to grams, I'm going to go to the periodic table and add up the molar mass of NaCl. From the periodic table, I know that 1 mole of NaCl is equivalent to 58.44 grams of NaCl. Now my units cancel out, and I'm ready to solve for grams. I'm going to multiply across the top, multiply across the bottom, divide my top by my bottom, and when I do that, I get 0.22 grams of NaCl. So I know that if I start with 10 milliliters of a 0.19 molar MgCl2 solution, I can produce 0.22 grams of NaCl. I hope that cleared up some solution stoichiometry. Please check out my other videos, and thanks for watching.